Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Today I would like to introduce one more new concept called order of minimization. Sir, we have seen in the previous lecture what is minimization and how to minimize any logical expression and what are the theorems which are helping us to understand the minimization process. Now let us try to understand what is the two types of methods of we can say what are the two types of methods in minimization process. Let us try to understand. So here we have seen in the previous lecture what are the available theorems in a Boolean algebra we have seen. Now let us try to understand what is the order of minimization. Basically we have two types of methods in minimization process when we are dealing with Boolean algebra, which are the first one is we can say SOP, and then second one we can say POS, which means sum of products, and second one is product of sum. Now let us try to understand the first one, sum of products. Here let us try to understand the first one, sum of products, SOP, sum of products. Sir, basically when we are learning about sum of products form, the output of sum of products form is always represented with 1. We can say the first point, output of SOP is always represents with 1, and the second point in the sum of products form, here every sum of product term is called as min term. Here each and individual, or we can say every SOP term is also called as min term. And also the third thing that we need to understand here, sir, SOP, it can also be represented as SOP standard form. SOP standard form can be represented as here we can say SOP can be represented as summation and then small n. This is the representation of SOP standard form. Now let us try to understand what is the order of minimization. So here the moment when we are dealing with any logical expression, when we are focusing on sum of products form, sir, the first priority is bracket, and then after bracket we just need to concentrate what are the complement terms. Here we can say that NOT gate is our topmost priority after bracket, and then we have to take the next priority is we can say that AND gate. Next AND gate we need to take as a priority, and finally we have to take OR gate. This is what our last priority is, OR gate. Sir, this is the order of priority when we are dealing about any logical expression. The first priority is bracket and then NOT gate, which means we need to check whether is there any complement term, or we just need to check, and then we need to make AND operation, and finally we just need to add, or we can say that we need to make OR operation. This is what the order of priority. Now let us try to understand what is canonical form, what is standard form, and what is min term. So now let us try to understand how to minimize using SOP form when we are dealing about order of minimization. Let us try to understand with an example. Sir, I told you already here the order of minimization when we are dealing about SOP. Sir, the order is, first of all we just need to take bracket, and then we can say NOT gate, and then AND gate, and finally OR gate. This is the order of priority I told you. Based upon this order, let us try to take one example and then we will try to understand SOP form minimization process. Sir, here let me take one example. Here y equal to, we can say a b bar c plus a b c plus here a bar b c. This is what an expression, we can say logical expression. Sir, here when we look at to this expression, here there are three logical variables, which are three variables, we can say variables, we can say which are a b c. Sir, here each and every individual variable is presenting in each and individual term. We can say that this is what one min term, and this is also one min term, and this is also one min term. Combination of different min terms we can call as logical expression, or we can say logical expression. Sir, here these are the three variables a, b, c, and now these three variables are presenting in each and every individual min term. So the moment when we find that the equation is having all the variables in all min terms, we can say that that particular logical expression is canonical form. Canonical form, we can say this is called canonical form. And now sir, this is an equation y equal to a b bar c plus a b c plus a bar b c. Now I told you in the previous lecture, even here sir, the moment when there is a, we can say it can be represented with 1, and then here b bar, which means complementing term, we can represent this with 0, and now c can be represented with 1, and here a can be represented 1, b1, c1, and now here a bar will be 0, and then b1, and then finally c1. So now to represent all these binary data, sir, we know that here this is 101 and then 111 and 110. We know the binary value, binary equivalent value according to 8421 code, sir, 8421 code, we can say that this value 4 plus 1, we can say the value will be 5, and now here this value will be 7, and now this value will be 3. So now to represent these values, sir, we can write like this: y equal to summation small m 5, 7, 3. This is the equation, we can say that the standard form, standard, we can say standard form of SOP. And now here we have seen already what is canonical form, and now this is standard form, and now let us try to understand what is minimal form. Now let us try to understand what is minimal form. Sir, here the equation y equal to a b bar c plus a b c plus a bar b c. Here y equal to a b bar c plus a b c plus a bar b c. Now from the above available these values, can we take here from first one and then second one? Shall we take here AC as a common? Yes sir, AC as a common. Now b plus b bar is the value, and now a bar bc. Now here according to Boolean algebra theorems, here b plus b bar is equal to 1. Now the remaining value will be AC plus a bar, we can say a bar bc. Now sir, let us try to understand from these two. Here can we take here c as a common? Now if we can take c as a common, y equal to AC plus a bar bc. Now let me take here c as common, c common, a plus a bar b. This is what equation. We know that when we look at to this equation, this is what distribution theorem. Here I can write as distribution theorem, distribution theorem. So now according to distribution theorem, we can write as here c into a plus a bar, and then a plus b we can write. Now a plus a bar we know that this is the value of equal to 1 here, C into A plus B. So now the final equation we can write as AC plus, the final equation we can write as AC plus BC. So this is what the final equation, y equal to AC plus BC. So now I can write this equation y equal to AC plus BC is minimal form. Here we can say that here y equal to AC plus BC, this is called minimal form. Minimal form or minimized form. Sir, this is called canonical form. Every individual variable is presenting in all the minterms, that is called canonical form, and the values which we are representing in standard form, and from the canonical form we have minimized with the help of different theorems, that is called minimal form. Sir, this is what SOP, or we can say that order of minimization of SOP. Now let us try to understand the second process, or we can say POS, or also we can call as product of sums. Now let us try to understand the second method. We can say that POS, product of sum. Here the product of sum, order of minimization here for product of sum. The second method we can say product of sum. Here order of minimization, let us try to understand. The first thing we just need to minimize, or we just need to give a priority for bracket, and then the second one we just need to give NOT gate, and third one OR gate, and finally AND gate. This is the priority for, we can say, order of minimization. And now let us try to understand what is the SOP terms and conditions. The first term here is the product of sum output. POS output is always represent with 0. And now the second point we can say here, sir, each and individual term we can say POS can also be called as max term. Sir, SOP can be called as min term, whereas POS can be called as max term. And third point here, the max term, or we can say POS can be represented with here pi, and then we can say capital M, pi and capital M with some values, we can say 1, 3, 7, something like that. Let us going to understand this model also. So now let us try to understand with an example what is the POS, how to make POS minimization. So here let me consider one example. Here y equal to A plus B plus C, and now A plus B bar plus C, and now here A plus B plus C bar. Sir, I told you in the previous lecture, in this equation we have three variables A, B, C, and now each and every individual max term contains all the variables. The moment when we find there is an equation, logical equation, which is having all the variables, we can say that that particular equation is canonical form. Canonical equation. This equation is canonical equation. And now from this particular equation, we just need to write what is the standard form. Here, sir, here A can be represented with 0, and then here B bar can be represented, complement value can be represented with 1, and then normal variable can be represented with 0, which means POS is exactly opposite to SOP. So now based upon this knowledge, here A will be 0 and B will be 0, C 0, A 0, B can be 1, and then C 0. here A0, B0, C will be 1. Now what is the values? Here all are zeros, we can say 0. And now here the second letter is 1, we can say the value will be 2. And now here the value will be 1. And now the moment when we try to write a standard form, here y equal to, we can write as y equal to pi capital M of 0, or we can say M0, M2, M1 we can write, or also we can write as y equal to pi M, we can write 0 to 1. This is what we can say that here this is called as standard form. Here this is standard form representation. Standard form representation. Standard form representation. And now let us try to understand what is the minimal form. Sir, minimal form, to understand, let us try to take here the first equation, y equal to a plus b plus c, and now here a plus b bar plus c, and now here a plus b plus c bar. From this equation, here we have 3 max terms. Sir, the first max term, here there is a complement here, and now the other remaining terms a plus b, and then a plus b is common, and then here c, and then c plus c is complemented. So now based upon these two, I will write it as a plus b plus c. After multiplication we can write like this, and then here a plus b bar plus c. So this is the equation. From a plus b we can write a into a we know that a into a equal to 1. So now based upon that concept, a plus b into a plus b I wrote as a plus b, and then c into c bar I wrote as a c. Now from these two we can write here b is, and then b bar is a b bar, and then b here complemented terms, and then remaining terms are, we can write as here a plus c, and then here b, and then b bar will be gets cancelled. We can say the final will be final output, we can say that a plus c. Sir, can I say that this is what minimized form? Minimized form. Yes, this is what minimized form of PYS. Sir, this is the process to understand SOP and PYS, or we can also say that this is the process to minimize any logical expression. Now